All right, welcome back to section 5.2, and now we're going to really see the power of using an augmented matrix to solve a system of equations by solving this system of 3 by 3. And you're going to see how much nicer it is than trying to do it with substitution and elimination. So I'm going to warn you, this is not easy the first few times you do it, and so don't get frustrated. It is a little confusing, and it's not like anything we've really ever done before. But I'm going to try to walk you through this, and so hopefully we'll make it easy to understand. So we want to find the solution to this system of 3 equations, and step 1 is to write it as an augmented matrix. So line 1 would be -4, 0 for y, 2 for z, and 14 as our answer. Very common mistake to leave out a number, to leave out, to just, very common mistake to accidentally put the 2 there. So make sure you're consistent. X is the first column, Y is the second column, Z is the third column. The next line would be -1, 1, -1, 12. And the next row would be -2, 0 again, -4, 22. So there you go. That's the way to do it. All right, let's remember now what we need to put, what the strategy is. The strategy is we need to get this number right here to be a 1. Okay? So you'll notice that in the past we would just divide row 1 by -4, but that's not going to be a great idea because that's going to give us fractions. So I have a better idea. Do you see how we have a 1 in row 2? Let's go ahead and replace row 1 and row 2. Let's just swap them, because remember, that's one thing we're allowed to do. So I'm going to swap row 1 and row 2. And as you can imagine, there's more than one way to do these, but I'm going to try to do the most simple way I can. Now, I've already made a mistake. Remember, when you're swapping rows, you need to be really careful to get the numbers right. So now the top row is -1, 1, -1, 12. Okay? So -1, 1, -1, 12. And the next row is -4, 0, 2, 14. And the third row stayed the same. So all we did there was we swapped row 1 and row 2, and so now we have a -1 in the top left. But we don't want -1, we want +1 in the top left. So now let's multiply row 1 by -1. So we multiply the top row by -1, and that will give us the following. 1, -1, 1, -12. So basically row 1 just flipped all the signs. All right, so I know that's a little hard to read. So that's 1, -1, 1, -12, -4, 0, 2, 14, -2, 0, -4, 22. So mission 1 is accomplished. We got a 1 up here. So now the next thing we need to do is to get these to be zeros. Okay, so I'm going to, first let's tackle row 2. I can multiply this by 4 and add it down, and that would make it a 0 in row 2. So we're going to replace row 2 with 4, we're going to replace row 2 with row 2 added to 4 times row 1. Okay, so that's going to give us a new matrix. Importantly, row 1 doesn't change, so just leave it the same. Now row 2, we do 4 times row 1 and add it down. So 4 times 1 is 4, and add it down and get a 0. 4 times -1 is -4. -4 plus 0 is -4. So it's 0, -4. 4 times this value is 4, plus that value is 6. And then don't forget to do it also over here. -12 times 4 is -48. And -48 plus 14 equals -34. Row 3 stays the same. Okay? If that didn't make sense, you should go ahead and re-watch that until it makes sense, okay? Now, Now let's replace row 3 because we need a 0 here. We need a 1 here and the rest of the column being zeros. So I can do that by multiplying by 2 and adding down. So row 3 equals row 3 plus 2 times row 1. This can also, as you can imagine, this can get tricky when you have lots of negative signs and lots of signs flipping. So you just need to be really careful. So let's do this. Let me scoot this up a bit. So we're going to do row 3. And so remember, I should maybe be writing these at the transitions between matrices, but so hopefully this is making sense. Okay, so row 3, we're going to do 2 times, well, first off, rows 1 and 2 are not going to change. Rows 1 and 2 we're leaving alone. Okay, so 2 times row 1 and add it down gives us a 0 here. 2 times -1 is -2. Add it down makes that a -2. 2 times 1 is 2, plus -4 is -2. 2 times -12 is -24. Add it down and you get -2. So 0, -2, -2, -2. So, all right. You can tell that as you get better at this, you're going to get a lot faster. So we got 1 and 0, so that's good. So the next mission is to make this number be a 1. And the way we're going to do that, the best way to do that, we could divide by -4, but then we're going to get fractions again, so that's not a good idea. What I notice here is, do you see how we have -2, -2, -2? If I divided that by -2, I'd get 1, 1, 1. And then I'd have a 1 here. So let's go ahead and swap rows 3 and 2 now. So what we're going to do now, and again, there's more than one way to do this, but I like to avoid fractions. So we're going to swap row 2 and row 3. So the top row stays the same. Row 2 becomes row 3, like that. That's 0, -2, -2, -2. And the bottom row then becomes 0, -4, 6, -34. Okay, so now let's see where do we go from here. So again, we want a 1 right here, and we can do that by dividing by -2. So row 2 equals row 2 divided by -2. So row 1 stays the same. Now, by the way, you could have done these 2 steps at once, and that would have saved a little bit of space. But when you're starting out with this, it's probably a better idea to just do this 1 step at a time. So now we're going to divide this by -2, which gives us 0, 1, 1, 1, because divide all those by -2, and the bottom row stays the same, 0, -4, 6, -34. We're almost there. We have a 1 here in all zeros. We have a 1 here. Now we need a 0 below there. So a 0 right here. So we can do that by taking row 3 and replacing it by 4. Row 3 plus 4 times row 2. And then we're on the home stretch. Top row stays the same. Second row stays the same. The third row, we do 4 times the row 2 and add it down. So that's going to be 0. 4 times 1 is 4. Add it down and get a 0. That's what we wanted. Times by 4 here. 4 times 1 is 4. Add it down is 10. 4 times 1 is 4. Add it down is -30. And just like that, we are ready to go. We have 1, 0, 0, 1, 0. So now we can take this last part and go straight to z. 10z equals -30. And again, you could divide by 10 here and divide by 10 here, and that would be the same as what we're about to do. Divide both sides by 10. Z equals -3 because those zeros cancel. And just like that, we are over the hill. We've got the first variable, so now we can work backwards to get x and y. So you can use any row from any matrix that you want at this point. So I'm going to use this row, the 0, 1, 1, 1, because that has, we want to use something that has a 0 for x so that we can get y. So I should say you can use any row that has a 0 for x now. So this row right here, the 1, 1, 1, is the same as y plus z equals 1. Do you agree with that? Y plus z equals 1. So z equals -3. So y plus -3 equals 1. Add 3, y equals 4. All right, one step away now. Let's use, we can use any of the starting equations if you want, or you can use any row that you want. Let's use this top row just because there's no y's in it. There's only x and z. So I'm just going to rewrite it. -4x plus 2z equals 14. We can plug in, there's no y's to worry about, so plug in -3 for z, -3. So -4x minus 6 equals 14, plus 6 plus 6. -4x equals 20. Divide by -4, divide by -4. X equals -5. And we are done. The solution is -5, 4, -3. What I recommend you do is, now that you've followed this whole thing through, is I recommend you grab a piece of scratch paper, write down this system, and try to do it without looking at this, as practice for doing it on your own. Believe it or not, I've done this so many times that I can do it really quickly. Every now and then I'll make a mistake, but most of the time I can do it pretty quickly. And after some practice, you will be the same way as well. So I hope you like what this is. The first few steps are typically the hardest because you have a lot of different things you can do. But hopefully I went through this slowly enough that it makes sense to you. In the next video, we'll look at another example of solving a 3x3 system with an augmented matrix. See you there. Please remember to like and subscribe if you found this helpful. Thanks.